There are many urgent problems and challenges that the world faces, but they require that disciplines come together, and where one needs to understand the entire system, from the molecule all the way to a potential device or engineering system. To achieve this, a whole new generation of scientists are needed that can discover fundamental principles, but also know how to turn these into working technologies. That is why we have an exciting master's program in molecular systems science and engineering here in Heidelberg, and we hope you can join us.
Molecular Systems Science and Engineering is a 2-year full-time master's program at Heidelberg University with an interdisciplinary and research-oriented curriculum. It aims at students with a bachelor's degree in the natural sciences who are eager to tackle the challenges of molecular systems and their engineering with novel and creative approaches.
The first part of the program offers a wide selection from topics from the field of molecular system science and engineering, ranging from energy conversion, nanomaterials, biosystems, molecular engineering, and many more. The courses are taught by researchers from the IMSIA, the Institute for Molecular Systems Engineering and Advanced Materials, as well as by researchers from other departments and institutes within Heidelberg University, and last but not least by researchers from other universities in Germany and abroad.
Our program aims to prepare the leaders of the future. For that, we will also offer additional courses covering from data and project management to technology transfer or ethics. Solving complex problems require knowledge and understanding, but also creativity. The Creative Science Lab is an open lab where students work in teams and are free to choose how they want to address the proposed challenge. The goal is coming up with creative and interesting approaches and test a hypothesis. In the second year, all the acquired knowledge and experience will be put into practice in the lab rotations and master thesis.
Hi, I'm Dirk from the Backgrou group and I'm working on synthesizing new polymers. We're not only synthesizing them, but we are also characterizing them using techniques like the GPC, and our goal is to 3D print them on a small scale using the nanoscribe, but also on a larger scale using the DLP printer.
I work on fabricating and designing micro and nanostructures. In particular, I want to design propellers that can be moved around using magnets, and these can be functionalized chemically to transport drugs, which would be very useful in, for example, nanomedicine.
I'm working on the diffusion of micro and nanoparticles through different types of membranes and biological tissues, and for that we have two different setups, one using pressure, the other one using electrical fields to determine which particles can make it through a certain type of membrane, which is a very important factor in drug application.
I'm working on thermoresponsive hydrogels. The structures are fabricated inside microfluidic chips by 2-photon polymerization direct laser writing, and we are using the chips then for biocompatible filter applications.
My project is to understand the charge transport in organic solar cells so that we can come up with methodologies to move past the theoretical limit that was set by previous calculation. Here we have a noise measurement setup which measures the temperature of the charge carriers in the system so that we have an insight in how the charge carriers in the system move.
We hope you are as excited as we are about molecular systems science and engineering, and we invite you to apply to our program.